Hello, everybody, and welcome to our webinar, ClickHouse Unleashed 2020. We'll be reviewing our favorite new features for your analytic applications, brought to you by ClickHouse and the ClickHouse community. Before we dive into this webinar, I'd like to bring a couple things to your attention in case you're a new attendee. So this webinar will be recorded. We will send you a link with both the recording as well as a link to the slides. You don't need to take frantic notes. We'll get that out to you. Another thing, we have a number of people on the call able to answer questions. If you do have questions as we are proceeding, feel free to pop them into the question and answer box. You should be able to find that in the control panel. And we will answer some of them in the background, but we also have some time at the end of the webinar to discuss them as well. Final thing, speaking of the end of the webinar, we will run a very short poll with 3 questions. It will take you about 15 seconds to fill out. We'd appreciate if you stick around, fill that out. It's just basic information, helps us understand how we're doing on this webinar and what additional topics you'd like to see in the future. With that, I would like to go ahead and dive in. Let's start with a few introductions. So on today's webinar, we will have Alexander Zaitsev. He's the Altinity CTO and also a founder of Altinity itself. He has decades of experience designing and operating petabyte scale analytic systems. And Alexander has been directing a lot of the work, in fact, almost all of the work at Altinity related to new ClickHouse features. So definitely an authority on the subject that we're touching on. Second, it's my great pleasure to introduce to you Vitaly Zakaznikov, our QA architect. He's a really outstanding QA person, great experience testing hardware and software. He's the author of Test Flows, which is an open source framework for testing that was just added to the build system in ClickHouse. It's something that we use for all our tests. Another thing, Vitaly is the author of the Live Views feature, so he's not just testing the interfaces, he's building them as well. And then finally, for me, I'm Altinity's CEO. I've been working for over 30 years on databases. ClickHouse is database number 20. And I think it's fair to say, for the purposes of this talk, we all love databases, and so it's our pleasure to talk about these many features that have recently appeared in ClickHouse and constitute our favorites. What we're going to do in the talk today is talk about 3 general areas. We're going to talk about storage improvements, we're going to talk about security, and then we are going to go ahead and talk about a couple of specific features at the level of SQL and the ClickHouse server itself. There are, of course, many more things coming in ClickHouse. We don't want to make anybody feel bad. There are over 500 people have contributed features or code of one kind or another to ClickHouse. So it's really hard to pick our favorites. We're happy to answer questions about the other ones as well, and we'll get to more of them in later talks. With that, let's dive in and talk about storage improvements. And I think the way to start this out is just to say what a difference a year makes. This time last year, which would have been early August, if you were running ClickHouse, you were basically going to have a single mount point for your data, so that basically you'd have a single device that would contain all the data for your tables on each ClickHouse node. That has changed enormously over the last 12 months. So one of the big things that has enabled this is the introduction of storage policies. And what these do is allow us to attach additional disks to ClickHouse. So these are additional mount points, which are then organized into volumes. This has a terrific impact on both performance as well as the efficiency of ClickHouse. And I'd like to walk you through a few of the things that are going on. I think you'll be really amazed at how many changes there have been. So let me just talk a little bit about how these are configured underneath. So if you use ClickHouse right now, you know that ClickHouse developers love XML. So the storage configurations are described using a storage configuration tag that splits things into disks. These are your mount points, so your locations for data. There's one called default, which is so that if you don't make any changes, ClickHouse continues to work as it did before. And then you can add as many additional mount points as you like. There's an example shown here. The second part in the storage configuration is what are called policies, which allow us to combine these mount points or these disks flexibly into volumes, and then also specify ways that the volumes are related to each other. In this particular example, I'm showing showing what we call JBOD, just a bunch of disks, where we combine 4 volumes together to to basically spread the data across each of them for tables that use them. So the way that you actually access these storage policies and use them inside ClickHouse is through a new setting called storage policy that appears on Create Table. So here's an example. We have a table called trip data, and you see underneath settings storage policy equals EBS JBOD 4. That refers back to that XML configuration that I showed you on the previous slide. And what that tells ClickHouse is that when it actually writes data to these tables or reads data from the tables, it needs to go look at the storage policy to figure out which mount points things are located on. Now, when this first appeared, I have to say that I was a little bit unimpressed. I thought, well, how useful could JBOD be? Well, fortunately, there's the Amazon cloud. This is an example of one of the things that you can do with this JBOD configuration. If you use Amazon and you're deeply familiar with block storage, you may know that there's a limitation in the bandwidth that's available for each EBS volume. So particularly when you have small instances, it is difficult to really scale up the performance. One of the things you can do with JBOD is you can attach multiple EBS volumes to your ClickHouse instances. And this graph on the right side shows you the effect. These are hot and cold runs. So the blue runs are cold. They're going to directly to storage for queries, and we see 1, 2, and 4 disks. You can see there's a drastic improvement in performance, particularly as you jump from 1 to 2. Once you're hot, of course, by which we mean that the data are in cache, it makes no difference because it's already reading from out of the OS page cache. So for the hot runs, you can see that they're basically the same across 1, 2, and 4 disks. But this is a really interesting feature that's an example of not only scaling performance, but scaling in performance in a way that's particularly useful for public clouds. Now, JBOD is just one type of storage policy that we can use. One of the big motivations or sort of end goals that we've had in this work is to go ahead and actually get to something that's not just a bunch of disks that you write to, but what we call tiered storage. And the basic idea with tiered storage is to be able to match, excuse me, sorry about that, just need a drink of water here. Okay, so the idea with tiered storage is that when you look at data, particularly time-ordered data, a very large number of your queries are going to run on the most recent data. And as you go from days to weeks to months to years, the number of queries that you're going to run on them are going to fall off almost exponentially. So what tiered storage does is allows you to match storage to the level of access that you need for the data. So for example, you can use NVMe SSD to host your most recent data, say over the last day or the last 12 hours. It then flows to high density disks, which are cheaper but store a lot more information. And then finally, and this is sort of the holy grail for this, for very old data and for very large volumes, to actually be able to store on object storage. So all of these are actually available right now, although object storage is still in development, and I'll be digging into it in just a minute. So let's just have a look at we won't go into the details of doing, so configuring tiered storage. We have blog articles that cover this very nicely. What I would like to do is just jump in and talk about S3, which is the newest storage type that we are working on adding together with other people in the community. And the slide that you're looking at right now shows an example of the S3 disk conversion. Of course, if you're an Amazon person, you know that S3 is Amazon's object storage, it uses an API that's supported by many other products as well. So here's an example of how it's configured. We call the type S3. We give the endpoint, which is pointing to an S3, a location in an S3 bucket with a prefix on it. And then we give the access key ID and the secret key for Amazon. That's it. At that point, you now are able to have ClickHouse reading and writing directly from object storage instead of local storage. So let's look at what the effects are. Well, one thing that's kind of interesting is when you start to write to object storage, you quickly realize that this is very different from the normal block storage that database engineers are used to. So we have things like metadata operations are very slow. Things like inserts proceed slowly. And there's also a tremendous benefit that you don't, with block storage, you can basically write stuff very fast, particularly if you're going to SSDs. You can just use single threads to write. With object storage, parallelization is really important. So this graph that we're showing shows the difference between a couple of different runs, and the effect is that things are fairly slow when we're writing with single threads. One of the things that we've been focused on with our recent S3 work is to enable multiple threads to do parallelization, to do parallel access, both reading and writing to S3. And so what you see is the difference when you have 2 threads versus 8 threads. And what we're looking at with the blue, that's the reference implementation, where we're actually writing to block storage, in this case EBS, and the red is the S3 performance. And so what you can see as you go between these two graphs is that the S3 performance is actually starting to become, in some cases, very close to EBS. This is a really, really big breakthrough because object storage obviously can hold enormous amounts of data. Moreover, object storage has a much different cost profile from block storage. It can be as much as 10x cheaper for typical usage. So this is a very interesting development and something that we expect will hit production readiness in the 20.6 release. So this is really interesting and fun. There are more things coming though related to storage. Another particularly interesting option is something called compact parts. So if you're familiar with the way that ClickHouse MergeTree tables are organized, you'll know that there is basically a .idx file, that's your primary key. That's your sparse index to find rows. And then you have .bin and .mrk2 files for each column. So the .bin is the compressed blocks, the .mrk2 is the offsets into those blocks, which correspond to the index granules. What compact parts do is they have the same information, but they vastly reduce the number of files that are necessary to store it. This turns out to have major performance impacts. And to dig into this more deeply, I'd like to go ahead and turn this over to Alexander, who's going to talk a little bit more about the design as well as the performance of compact parts.
Yeah, thank you, Robert. Hello, everybody. So we can actually go to the next slide for the detail. So the idea of compact parts is certainly reducing the number of files, and you will see in a minute how it works. But internally, we still try to keep the same columnar structure. So data is still stored in columns. Inside the big compact part, there are mark files and binary files, and ClickHouse just knows offsets of proper file chunks. What it means is that it's much faster for inserts. And the original design idea was to make inserts, especially small inserts, faster. If you experience with ClickHouse, you know when you insert data too fast and in small chunks, then ClickHouse doesn't perform well, and you may get into some problems. So those compact parts were focused to fix this problem. From the other side, when we need to query data, it performs worse than original columnar design, because ClickHouse has to do file 6, and it's not as efficient as reading files. What's interesting is that when we were testing S3 performance, we figured out that using compact parse makes a lot of sense because it vastly reduces the number of files and file operations. So with compact parse, you can insert data in S3 much faster comparing to original wide parse. But query side is still a concern, and we're still working on improving the performance here. Next slide, please. This is the example of file structure for wide parse and compact parse. As you can see, for a table that we used for test on time dataset, we had 224 files in wide part and only 8 files in compact part. This is a huge difference. A huge difference, and as I mentioned earlier, it shines on inserts, especially when you insert small data. What happens next, and we can go to the next slide actually. ClickHouse moves the data between different part formats. And quite recently, there were introduced memory parts. This is a third type of part, which is stored in memory with write-ahead log just in order to make things reliable. And the idea is that if you have very small inserts, they go to memory. Then merge process takes them and puts directly to the wide part or to intermediate compact part if it's necessary. Thus reducing the amount of file operations and making it much more optimal than originally. With this design, for example, you don't need to use buffer tables at all. And you can use memory parts as a replacement for buffer tables, and it's more convenient. Let's go to the next slide for some performance figures. Unfortunately, I couldn't do a very good test. It's kind of ugly, but it still shows the difference. There are 3 different tables, and they're created in a way in order to enable the different parts types internally using these parameters, min rows for wide part and min rows for compact part. And I'm inserting single row. So if you look at the insert statement, there is a settings max box size. It actually forces ClickHouse to do inserts in a single rows. And thus we emulate the amount of insert operations per second somehow. It's not 100% true, but it's close enough. And as you can see, once we go from a wide part to compact, we have a performance improvement, probably not as dramatic as I would expect, but still notable. And when we go to memory part, the performance improvement is 70%, something like that, which is even better. So having said that, this is a new functionality. Their purpose is to enable frequent inserts, frequent and small inserts in particular, and I appreciate any feedback on that and go and use it. Let's go to the next slide. Another interesting thing which already exists in ClickHouse is TTL. TTL started with delete when ClickHouse could automatically delete parts or partitions that was stale enough, old enough, using some time constraints. And we started to extend this functionality with move, and this is where tiered storage works. So you can define that you can move the data between different volumes automatically. So no manual intervention is required. But community picked this feature and continued to add some new interesting flavors of TTL expressions. For example, in 20.5, we have TTL delete where, which allows you to specify extra condition for the rows that needs to be deleted by TTL expression. And last but not least is a very interesting feature, TTL group by. Let's go to the next slide to see what it does. So a TTL group by idea is to perform automatic roll-up of data once time condition has been reached. For example, you may have detailed data for the last day and then roll up to minutes, or after 30 days, roll up to days, losing the minute granularity or whatever. And in order to do that, you define TTL expression. So here in this example, I define TTL expression with a 1-day TTL that groups data by 3 columns. And those 3 columns has to be the prefix of primary key. And then it applies some aggregation function. Instead, you specify aggregation function that needs to be applied. It could be sum, it could be count, it could be any ClickHouse aggregation function. So this is kind of cool feature that allows you to reduce accuracy of all data automatically without some difficult and complicated coding around. Let's.
Okay, so thank you, Alexander. That was great. And what I'd like to do now is switch gears just a little bit and talk about security features. So as ClickHouse has gotten more enterprise usage and is sort of outside of the realm of sort of the early adopters, people are asking for a number of features that help improve the security and access to data. So there's a long list of things here. I won't go through them in too much detail. I'd just like to highlight a couple that that are particularly useful. We're going to go do a deep dive on LDAP and RBAC in the slides that follow. Another kind of interesting thing that's coming in is AES encryption functions. So, and in fact, I'm happy to say at least one of the folks that helped sponsor this is on this call. We have added functions that are very similar to the MySQL AES encrypt and decrypt. Gives you the ability to add high quality encryption to values on individual columns. This is the first step in the direction of having something along the lines of transparent data encryption, where ClickHouse will be able to manage keys, will be able to use or sort of implement encryption regimes that are suitable not just for protecting data in general, but more importantly work in multi-tenant situations where you have different keys, you have keys rolled over. This is the tip of the spear is starting to appear with the AES encryption functions. We expect to see it built out beyond that. So there's a lot of great features that are happening here, and what I'd like to do now is turn things over to Vitaly Zakaznikov, who's going to dive in and talk about RBAC followed by LDAP. So Vitaly, take it away.
Hello, everyone. So we'll quickly touch on the new feature that came to version 20.4, which is role-based access control. It's a very exciting feature as it provides SQL statements to control users, roles, role policies, setting profiles, and quotas. As you can imagine, having SQL statements, greatly simplify access control and user management, especially for multi-tenant systems. So with role policies that came with RBAC, that brought support for role level security. So there's a type, it's no role, it's role level security. So which enables you to provide access to users or roles, that would enable access to a specific part of the table based on a filtering expression. And with the RBAC, the feature provided a fine-grained control over the privileges so that you can control how which users and role have a specific privilege to enable, a specific control over which statements they can or cannot execute. And it's a hierarchical structure to enable easier control. We can move on to the next one. So how would you enable RBAC, right? By default, RBAC is disabled. So it's pretty easy. There's two parts to it. First, if you want, you can specify a directory for where configurations will be stored. So that is done inside your config.xml using the access control path setting. And by default, it's set to varlib ClickHouse access. Then for user that you would like for it to have the access management, so for users that you want to have access to execute, to create users and manage the access, you need to enable the access management setting. So as you can see below in the slide, there is an example. If we want to allow the default user to have to create other users and grant rights to them, then you can set the access management setting to 1. And then you have to restart your server. And then if you log in with a default user, then you'll be able to create new users and grant rights to them. So, so RBAC SQL statements. So RBAC provides the SQL statements. So what can you do with them? So I broke them up into some groups. So for user management, you now have create, alter, drop user statements that can allow you to create, alter, and drop the users. Then there's a special show create user statement that will allow you to see how the user was created. The same is available for the roles that you can create, alter, drop, set the role, as well as you can have set a default role for the current user. So if the user have multiple roles and you want to just work, you know, set a given role so that you don't do something that you don't want to do, then you can limit your privileges by setting a specific role for the current user. And then show create role will allow you to see how the role was created. And the roles are really nice because they will allow a group of users to share the same role, right? So you don't have to assign the same privileges to each specific user. Roles will enable you to assign privileges to a role and then assign roles to your users. Then the exciting access controls. So given that we have privileges, how do you grant and revoke them? Well, using the grant and revoke statements. And then there are role policies, so that which bring the role level security. So you can create, alter, and drop them with a create, alter, and drop role policy statements, as well as you can see the role policy using show create statement. Then in addition to just access, you know, with RBAC, there's ability now to create settings profiles that you can also associate with users and roles. And there are now create, alter, drop settings profile statements, as well as show create settings profile to see what the profile is. And you can now limit or assign quotas, right, to your roles and users using the create, alter, drop, and quota statements, as well as you can see what the quota is using the show create quotas. So all these new statements really allow you to manage your users, you know, manage your roles, you know, grant and revoke access. You know, your admins can now have easy access to, you know, how they manage the ClickHouse cluster and the tenants inside your database. All RBAC, you know, is what it, the main point of it is provide the privileges, and privileges provide permission to execute specific kind of queries. There are a lot of them, and you can see that in the ClickHouse documentation, the whole list of all those privileges. But the important part to know that privileges have a hierarchical structure, and there's a few special privileges. So one of those special privileges is the all privilege that can be used to grant all the privilege to a role or a given user. There's also special privilege none, that when you're creating a user or role, you can just specify non-privilege so that no privilege is assigned to that role or user. And the last two is the admin option and the grant option. The admin option privilege allows a user to grant its role to another user. Otherwise, you know, only the user that has the access management setting set to 1 will be able to do that. And when you're granting a privilege, if you specify grant option, then it will mean that that user will be able to grant that privilege to another user of the same, so the privilege of the same or a smaller scope. Next slide. So here we have an example of how the hierarchical structure of RBAC privilege, because there are a lot of them, and it would be tedious to just you know, manage all the privileges individually. The hierarchy was created. So for example, alter column privilege control has a sub privileges like alter add column, alter drop, modify, comment, clear, and rename. And those map to corresponding actions, right? Commands, you know, statements that you can execute, you know, inside the database. But you can control all those sub privileges using the alter column privilege, which itself belongs to the alter table privilege, which itself belongs to the alter. So if you want to just give your user or role the control to execute the alter statements, any commands, you know, so you will just grant alter privilege generic. If you want to be very specific and for a given user or role, you would just want to enable them to add a column, then you can just grant alter add column privilege. Next slide. So Here's a slide that would provide, an example of how these statements can be used. So I picked a few of them. There are many more variations, and we encourage you to try this exciting feature to see how it works. So for example, the first statement is how would you create a user? So you can create for example, user account mirror with some password query just by executing create user mirror, identify with, if you want to use SHA-256 password, then you give the password query. It's very easy. You can do it just on using your ClickHouse client. Similarly for altering a role, if you have one role and you want to rename it, you will just use alter role command. For granting and revoking, so we will use the grant and revoke statements. So for example, there is a select privilege that can specify a privilege to read from a specific column or tuple of columns. You can specify which columns you can grant access to. So for example, grant select XY will grant, access to the X and Y column on some table, to a user. For example, John was a grant option, and the grant option again will allow the user John to potentially grant this privilege to some other user. And if your admin wants to revoke a role from a user, he or she would use just a revoke role command, statement, and then you would specify either role or user. And similar for create role policies and create settings profiles, you would just use the corresponding statements, and then you'll be able to assign those settings or role policies to a specific user or role. Next one. So that was a quick introduction, to the RBAC. If you want to know more information, we recommend that you check out the documentation at clickhouse.tech. There's actually a page listing all the privileges, and you can see how they map to the SQL statements that you use in working with ClickHouse. Another exciting feature that came, that relates to security is that now you are able to authenticate users using LDAP. So before, you would have your users defined in your users XML, and there you would define passwords. That's very cumbersome, when you have a large organization, because now users must have specific passwords to just enter the ClickHouse database. So with LDAP authentication, that process becomes easier, because now you have an option to is have an LDAP server, and then instead of specifying a password, specifying which LDAP server should ClickHouse use to authenticate the user. So that feature appeared in 20.7, and it's still in the testing stage. As I mentioned, it really simplifies, user password management. You no longer need to store passwords in your users XML if you have an LDAP server in your organization. You just have to update your user definition to specify which LDAP server to use instead of a hard-coded password. And the implementation supports secure connections, so that passwords are not transmitted in plain text. You have the ability to specify one or more servers, and each different users can be authenticated using different LDAP servers. So the implementation is very flexible. So we can go and see how would you go ahead and switch to this to using LDAP user authentication. So first you need to define your LDAP server. So the descriptions go into the config.xml, or you can create a separate XML configuration inside the config.d directory, which is usually the recommended way. So you can you will define an LDAP service section. In there, you can define your service. So we provide in this slide an example how you can define my LDAP server, where you would specify the host, the port. You would specify if you want to enable TLS connection, which secure connection. By default, it's set to yes. And then you are able to specify the DN prefix and suffix. So that will be used to contact the LDAP server and check the password that was provided to ClickHouse. Next one. So once you have your servers defined, it's very easy to switch users to use LDAP for authentication. So you would go to your users XML, for example, if that's where you have your users. And then, for example, if you have user underscore name, then you would remove the password section and you will add the LDAP section, where inside there you would specify which LDAP server you want to use to authenticate that user. Then you can restart your server, and it will be you'll have access, the users now, anytime they specify the password, then a request will be made to the LDAP server, which will be either, your password will be either verified or rejected. And if it was rejected, then the user will not have access to ClickHouse. So next slide. So here's the simple workflow. So again, how would you go about enabling that feature? So first you would define LDAP service inside your config.xml. You would then convert users user definition to use those LDAP servers or a server. Then you will restart the ClickHouse server, and now your users can be authenticated using LDAP, and you no longer have to store passwords explicitly just for ClickHouse inside the user.xml file.
Okay, so thank you very much, Vitaly. One thing that I think is worth adding on LDAP is this is just the beginning of LDAP support. We do expect to eventually be able to hold the users in their entirety in LDAP, as well as other types of identity managers. So they'll definitely keep an eye on this. There's more stuff on the way. For the final section of this talk, we'd like to discuss a couple of new ClickHouse features. And for this, I'm going to turn it back over to Alexander Zaitsev, who's going to lead us through two final interesting features.
Yeah, thank you, Robert. So actually, it's very hard to pick some new features in ClickHouse because there are too many. And I picked some related to dictionaries because it actually opens up some interesting new capabilities. And later on, we'll talk about some JSON processing improvements. So there are quite a lot of work around dictionaries quite recently, starting from dictionary DDLs later in 2019. You now are able to create dictionaries just like tables with create dictionary SQL statement. So it's a first-class citizen in ClickHouse. And since then, there was some interesting changes added. First, starting from ClickHouse 20.4, ClickHouse can now automatically rewrite joins. If you join the dictionary, because it looks like a table, you can join it. Then ClickHouse automatically rewrites it to dictionary calls, which are more efficient. This is kind of cool feature because it allows you to define dictionaries, but use the normal SQL joins. And this is very friendly to users, BI tools, and everything. Next, I will talk a bit about new layouts, the direct and SSD cache, which has been added in 20.5, so you can use them already. And they are especially interesting when used together with dictionary sources for key value databases like Redis, MongoDB, and Cassandra. And Cassandra has been added in 20.5 as well. Next slide. So this is an example of join rewrite. So the query, if you have a query and you join a dictionary in order to extract some attributes, it gets automatically rewritten to dict get function calls internally. You don't need to do it by yourself. ClickHouse can do it automatically starting from 20.4 for you. And some details about why it matters you can find in Altinity blog articles back in May. So I don't want to spend a lot of time right now. Next slide. The more interesting is new layouts, and we'll start from SSD cache. Consider that you have a use case when your dictionary is too big to fit in RAM, but your dictionary source is too slow to use a cache layout. So if you have a cache miss, then you have to go to some external system to fetch the value, and it may be slow. So cache layout may not give you enough performance. What you can try now is SSD cache dictionary layout, which allows you to do kind of two-layer cache, both in RAM and on local SSD storage, if you have local SSD storage, of course. And ClickHouse will try to, driven by some parameters that you supply when you create this layout. So So ClickHouse will try to store as much data as specified in memory, and everything else cache in at fast SSD. And still go to your original source if there is nothing in local cache, in memory cache and SSD cache, or if the data in cache has expired. You certainly have expiration strategy controlled. With such two-layer approach, you can get much better performance comparing to cache layout or comparing to some other techniques. Next slide, please. But it's possible that your data is even bigger and you cannot even use SSD cache, or your data changes too often, so you cannot use a reasonable invalidation strategy. For that use case, there is a new layout which is called direct. With this layout, ClickHouse would always call the source, external source. It doesn't do any caching, it doesn't do any invalidation. If you call a dictionary with the get or whatever method, ClickHouse will always call your external system. And you certainly rely on external system performance, and you have plenty of things to pick from. There is Redis, which is supported quite long ago. There is MongoDB support even from 2018. I was actually surprised that exists for so long. There is a Cassandra support, which has been added in 20.5 release very recently. Aerospike support was planned, and somebody worked on that, but I checked before the webinar that the pull request is kind of abandoned. But I hope somebody will pick it up and complete, because Aerospike is a good technology. Or you can even use MySQL. You can do wonders with MySQL, especially if you read per corner block. They claim something like some enormous read performance with key lookups if you have everything in a DB cache. Next slide. Now we will talk a bit about JSON ingest improvements. We had a webinar earlier on how to do log processing, and the typical workflow is to take some logs, insert them into a staging table or some ETL table, we can call it this way, without a lot of processing, and then apply SQL using mercialized view in order to extract all necessary information from your raw data. This is a very neat approach, and it works fine, but unfortunately, in reality, so let's put in the next slide. So in reality, if you need to store JSON data, and it's quite often that your logs are in JSON, it's not a well-formed JSON. So next slide, you see that your JSON logs are typically not well-formed JSON. They are built from the JSON messages separated by commas. This is very, very common. And every message is certainly is well-formed JSON, but altogether, if you would try to load them into ClickHouse, it wasn't very easy. You cannot use any JSON formats, and ClickHouse has a lot of them, because it's not well-formed JSON. And you cannot use CSV, because you certainly have CSVs inside the JSON. Before recently, you had to do some tweaking, some extra processing in Bash probably in order to convert this into tab separated or whatever, or try to load this as a JSON array and then do some extra processing. It was not very convenient. Now we have a solution on the next slide. We have a new format which is called JSON as string, and this does exactly what we need. It takes the input and considers it as a sequence of JSON messages, comma separated. Voila, we have the data loaded in a table, and every JSON is in string. And now we can apply all rich JSON processing function that ClickHouse has in order to extract the data we need. There were a lot of cluster improvements, and it would take probably a full webinar to talk about them in detail, but I want to highlight some so you would know that this functionality is already available. First, there is distributed over distributed. So you can define distributed table that refers to other distributed tables. Then one of very long-awaited features is parallel distributed insert select. If you work with a cluster and if you need to copy data or part of the data from one distributed table to another distributed table, you may notice that it works slow. It worked slow before, because ClickHouse had to collect the data from all shards to the node where you're running the query, and then ingest it to the distributed table, right? And then do the distribution, etc. So you had a bottleneck on a single server. Now, with parallel distributed insert select, ClickHouse can do it in parallel on every shard. So just moving data locally from shard to shard. This is certainly much, much more efficient, especially if you have a bigger cluster. Probably one more interesting feature is distribution queue table, which allows you to see what data has been inserted into distributed table but not propagated to your shards. Before then, you had to go to the file system in order to see this. Now you have a thing in ClickHouse itself. And last, I would highlight 3 features that are coming in the next several months. One is database replicated, which greatly simplifies management of replicated tables. So in an essence, you would put your logic about how you create replicated tables inside the database, and then you just create a replicated MergeTree table, and it gets automatically propagated with a proper path. It's get automatically created on all replicas for this database replicated automatically. So that would make replicated tables management much easier. And 2 things about Zookeeper that are also coming. We started to work on Zookeeper replica recovery. So if you work with Zookeeper, I think everybody in the ClickHouse experience has lost Zookeeper at least once. And you know, if you lost your Zookeeper, then your replicated table kind of turned to read-only mode, and they're not very useful only for queries. And it's very long and painful process if you want to recover your Zookeeper. So we started to work on a feature that would allow you to do it with a single SQL statement. And in parallel, there is a number of changes which is going inside ClickHouse and is driven by core ClickHouse team. Those changes at the end should allow us to continue inserts and writes if Zookeeper is not available. So right now, if Zookeeper is not available, you are in read-only mode, and if you have insert and TensorFlow clothes with some real-time systems monitoring and stuff, this is not very good. And so with this change, you can continue to write to ClickHouse even without Zookeeper, and ClickHouse will operate almost normally. It just cannot merge the data from the old parts and new parts that have been inserted with partition Zookeeper, but everything else will continue to work as before. With that, I think we're kind of done, and I had control over to Robert again.
Thank you very much, Sasha. So we're going to do a short wrap up. I'd like to encourage you, we've had a couple questions come up. I'd like to encourage you to ask more questions about these features or anything else that you're interested in ClickHouse. We have 4 people here ready and willing to answer questions. So just at a high level, as you can see, the takeaways, sort of the focus of recent developments have been particularly around storage, just an enormous amount of work there. And then particularly around security, as we begin to sort of thread in some of the enterprise level features like RBAC, which has been a community request for years at this point, and it's coming in and really getting the sort of the level of testing that it needs to be for people to count on it. And then of course, feature improvements around query optimizations of various kinds. The future for ClickHouse, of course, we're going to continue to work in all of these areas, but there are a couple of things that I'd like to highlight that are coming down the pike and you should definitely be looking for. The first is to make ClickHouse more cloud friendly. So you saw the tip of the spear on this, which are the thin edge, which is the S3 storage support, which is coming and will begin to allow us to take advantage of cloud services. But what we're really after is the ability to separate storage from compute. This is something that's the holy grail for cloud databases, and the goal of the community is to get there. It will come in incremental steps, but this is something that is now on the way. And it also includes things, of course, like being able to spend less time explicitly managing shards and replicas and more time just putting your data. ClickHouse will figure out the right place to put it using the right types of storage and then give you access to it. This is a multi-year project, but you're going to start to see these features coming up in the, for example, the next time we do this talk. Another area of great interest is SQL conformance. So things like improving, full support for common table expressions, basically, all the things that are necessary to have this become a fully compliant SQL implementation. We've never really been, on ClickHouse, we've never really been too worried about SQL conformance. We rather worry about doing things that are good for our users. But in the long run, if you want to integrate with BI tools and you want to make it as easy as possible, there's just a lot of standard SQL features that people expect in analytic databases. It's our goal to put them in. And then there's many, many other things beyond that. So with that, we're done for today. I really hope you've enjoyed this. This is like the best part, for me at least, speaking for myself, this is the best part of my job to talk about stuff like this. So we want to thank you. Go ahead and queue up questions. And I'm going to go ahead and launch the poll. If you don't mind filling out those 3 quick questions, we'll do that. And then but I want to just put up a couple things. First of all, if you're interested in finding more out about ClickHouse, learning how to use it, we offer a free 1-hour consultation. Go ahead and contact us. The link is given below. And if you like this stuff and you're a developer and would like to work on it, we're also hiring. Check out our careers page. And with that, what I would like to do is go ahead. So please do fill out the poll. I see a few people filling it out. And then we're going to transition to questions. With this, I'm going to stop the share and we're going to go ahead and, here, let's stop the share and switch to video. We have a number of people available. I hope you guys can you guys see the video okay? Somebody can confirm?
I can see.
Okay, great. So we've got, and we've also got Mikhail Filimonov, who is another one of our experts. He is the maintainer of the Kafka engine and is joining us to answer questions. And question 1, Misha, it looks like you want to answer this question. If the Zookeeper is down, how to rebalance data once it's back online? Do you want to talk about that?
Yeah, actually don't usually when you're, can you hear me?
Yes.
Yeah, so if your Zookeeper is down, during what downtime, you can't insert data to that node. So actually that node don't do anything with your data. Data is safe, nothing is happening. Here, once you get your Zookeeper back, everything will just continue working. You don't need to do any rebalances or something like that. The thing here is just try to not lose the data in Zookeeper. Otherwise what recovery is more painful.
Great. And yeah, and so we had a couple of previous questions that you covered. so talking about performance and insertion rates, so I think those were already covered. One question that I would just ask, because it comes up really commonly, is, and Alexander, this is one for you, what about rebalancing of shards in general? Do you want to just talk about some of the thinking about that? That's such a common ask in the community. Not to put you on the spot, but it's an interesting question.
Thank you, Robert. Yeah, this is definitely an interesting question, especially interesting if you go to the cloud and you don't know your workload in advance, and you just want to be able to scale up when you need to. So right now there is no good solution for rebalancing. You need to use ClickHouse Copier to move your data between different clusters, smaller ones or bigger ones, or move parts manually in the background, which is kind of painful and error prone. We do have a design proposal internally in Altinity, and we discuss it with Yandex, how we can make rebalances easier to do, not automatically yet, right? But with something like system rebalance table SQL statement. And it's possible to do, probably not a very complicated project. We're just looking for companies who can fund it right now, because our resources are busy with doing some other stuff. If we will find funding, we will definitely do it in 2-3 months. This is not too complicated. And in the long term, there is a concept of cloud tables, cloud MergeTree tables, which has been published 2 years ago already in Yandex blog, Yandex ClickHouse blog. And this concept is still true. So there are plans to do that. But in order to build those cloud MergeTree tables, ClickHouse has to undergo a lot of internal evolution. And this evolution is currently happening. It's probably not visible to users and not visible to many developers, because it's a set of small steps, fix something here, improve something in Zookeeper, and so on and so forth. So it's common, and we expect those cloud MergeTree tables to be available something in 2022, maybe.
Great. I've got a question that just popped up here. I noticed that Zookeeper doesn't delete the data after being inserted on all nodes. Did I configure it wrong? Anybody want to grab that one? No volunteers?
What Mohammed means by data in this case. Misha, do you want to answer?
Yeah, actually, what Zookeeper stores, it doesn't store the data. It stores the meta information about the parts. So every time you insert the data inside ClickHouse, it creates a new part. The information about that part exists in Zookeeper not only just after insertion, but it's persistent there. So all the parts which are registered in system should be registered in Zookeeper, and that is like a source of truth, source of knowledge about the state of our replica. So if you will just join one more replica, it doesn't need, it just reads those list of parts which should be there and downloads it from healthy replicas. So that information persists there. It doesn't remove after it being synced.
Yeah, but this is, by the way, something that we're going to change in the future. So because right now, because of that, ClickHouse heavily depends on Zookeeper to be available. And nobody likes that.
We have sort of a campaign. I think that's a good point. And we've hit the top of the hour, so we're gonna have to close up here, but there is definitely a campaign in the community, and which we're involved with, to make ClickHouse kind of go away as an operational issue. I think that's the best way to put it. So you'll see continued improvements, and Alexander already introduced a couple more of those. So one final thing in closing, as you can tell from this presentation, we're deeply involved in the development of these features. We would like to thank the members of the community who have actually helped fund the development of these. If you do have ClickHouse features that are of interest to you that you'd like to see, come and talk to us. We're always interested in adding new features, particularly if you have enterprise problems that can be solved by them. So that's another reason to contact us and see how you can help add new features to ClickHouse to make it better for everybody. With that, I'd like to thank everyone who helped on this presentation. So Alexander, Vitaly, and Mikhail, thank you so much. It's a pleasure to do this talk with you, and great content. And for our audience, thank you so much for attending. We hope this has been useful. You'll get an email shortly with links to this recorded presentation as well as the slides. And if you have any questions, feel free to contact us. Thanks, and have a great day.
Thank you, Robert.